Section 1.6, number 55. Here we're given that f of x is the square root of x plus 4, and g of x is x squared. Now first we're asked to find f of g of x. And what that means is that everywhere where there was an x in f, we now put the entirety of g of x. So g of x plus 4. But g of x is x squared, so this is going to be the square root of x squared plus 4. Right. We are, in addition, asked to find the domain of f of g. Okay. So remember, this is an even root. Even roots don't like to have negative numbers put inside. So the question is x squared plus 4 ever less than 0? Right? This is the same thing as saying, is x squared ever less than negative 4? Now, since squares of real numbers are always greater than or equal to 0, this never happens. So our domain is everything. We don't have any problem points since the thing under our square root is always greater than or equal to 0. Right? So our domain of f of g is the entire real line, negative infinity to infinity. Okay. We're also asked to find g of f of x. So this, we take our g, and everywhere where there's an x in g, we stick our entire f of x, right? So this is going to be f of x squared. Okay. So it's going to be square root of x plus 4 squared. And when we square the square root, right, they undo each other. So this is going to be x plus 4. But there's a caveat here. We have built this thing from something where we had this x plus 4 underneath the square root. Okay? And the square roots, they don't like to have negative numbers put under them. So is x plus 4 ever less than 0, which is the same thing as x ever less than 4? Yeah, negative 4. And the answer is, of course, yes. Anytime x is less than negative 4, x is less than negative 4. So these points are not in the domain. So the domain of our function of g of f of x is going to be from negative 4 out to infinity. And we actually want a square bracket on this, since being negative 4 is fine, because x plus 4 is 0 at that point. So it's x plus 4 for x from negative 4 to infinity. Okay? So the domain of f of g of x, which is square root of x squared plus 4, is everything, but the domain of g of f of x is negative 4 to 0, and the function is x plus 4. So if we graph this thing, we're going to get these two functions. The blue is our square root of x squared plus 4. Okay? And we see that it has this nice curve to it. It exists everywhere. Now our other one, our red, is our g of f of x. This is our x plus 4 whenever x is greater than or equal to negative 4. So what we get is we get this straight line that ends at this point. This is actually a filled-in circle since it exists there. Okay? And it asks the question, is f of g equal to g of f? Well, it certainly isn't in this case. We get two distinct functions. We get a linear from the g of f, and we get the square root of this square of this quadratic from f of g. So they are not the same. So f of g is not equal to g of f. Okay? And we're done.